Hi everyone. Today we'll go for linear dependence and independence of vectors. What are the learning objectives for today's? So at the end of the lecture, you are in a position to define linear combination of vectors, linear dependence and independence of vectors. And if the set of vectors have been given to you, you can be able to check whether that those set of vectors are they linearly dependent or they are linearly independent. So what exactly combination is? So if I have this a1 bar up to an bar, these are the vectors. And if I have x1 and up to xn, these are the coefficients, then I could define my relation between them. If this relation x1 a1 bar up to xn an bar, if this is equals to my 0 bar, then only I could say that yes, these vectors a1 to an, these vectors are in linear combination with each other. What is the after defining the linear combination, we will go for the solution, right? We will go for the solution. So this combination are called trivial as in this is a trivial if the coefficients x1 up to xn all of them are zero. So we are defining the trivial solution if I have all the constants or all the scalar multiples, they are zero. And they are known as non-trivial obviously if at least one of them is non-zero. Then what is linear dependence and independence? So the vectors, again, I am taking the same set of vectors, a1 bar to an bar. So now here if are called linearly independent if there is no non-trivial combination of these vectors is equals to zero vectors. In short, if there will not be any relation between them exist like this as usual. Okay, just give me a second, guys. Yeah, then I need to go for my, so it will be visible for, yeah. So, yeah. So it's linearly independent. If this is what is a relation we have seen in the linear combination, and if in this linear combination, if I have all the constants or all the this x1 to xn, all of them are zero at one go, then what will happen? This relation such relation will not exist. If this relation will not exist between them, that means what? They are linearly independent. The vectors are linearly independent. Then what will happen if they are dependent? That means at least one of them, like x1 to xn, at least one coefficient should be non-zero. Then only I could say that, and then only it's possible for me to define such a relation between the vectors. And therefore, in that case, the vectors are said to be linearly dependent. So what is the, in short, I could say that the vectors are linearly independent if all the coefficients are going to be zero. They are zero. But if I wanted to define dependence, then at least one have to be non-zero. I'm not saying it's all, at least one have to be non-zero. Very important definitions to note. No, so let us go for the example. So we have given here a bar, b bar, and c bar. Now, if you'll observe the components of these vectors, they are 1, 1, 1. That means how many components have been given to me? They have given to me a bar as 3 components. Under that, under the a bar vector, I've got 1, 2, 3 components. So if I have this a bar of this order, my other vectors have to be of the same order to check whether they are linearly dependent or independent. If there is a difference between their you can say the number of components, you can't go for the linear dependence or independence to go for, right? Okay, as we have seen that if I have a 3 vectors, I need 3 coefficients. So I'm not changing here the notation. Let me go with the same one. That is x1, x2, and x3. These are the 3 coefficients I've taken. Now in this coefficients, so it's what will be the combination? So this is nothing but it's known as the linear combination. The relation between this, if this is happening and I have to check, so I wanted to check whether they are linearly dependent or independent. That means it is completely will depend on the values of x1, x2, and x3, right? So x1 a1, x1 a bar, x2 b bar, x3 c bar is equals to 0 bar. So after this, I'm putting the value of, so I'm putting x1 into 1 1 1. That means what? I have got my, so I'm just replacing my a bar with 1 comma 1 comma 1. Similarly for b bar, similarly for c bar, right? So it's equals to 0. Now after that we need to form this type of equations. So but how can we do that? So this is, let me just do that with a pointer so that you will be, yeah. So if I wanted to find out my first equation, so if I wanted to go for this equation, I need to first change this, the vectors, arrangement of a vectors in terms of in terms of matrix. So it will be easy. So you can say that this is also one of the best application of a matrices. So this is 1x1, right, plus 1x2 minus 0x3 is equals to 0. So this is my first, actually this is 0 bar. So 0 bar means what? I have got it here, 0 comma 0 comma, go my to my first component. So this is nothing but first. So x1 plus x2 is equals to 0, my first equation. Second would be like this. It would go like this. It will go from here. Then that means it is x1 plus 2x2 minus. Actually, I think I made a mistake here. This is, consider this as, instead of minus, consider this as a plus. I'm sorry for this. This is plus. Please make the note of this. This is plus sign. Then it is minus of x3 is equals to 0. So I've got my second equation, x1 plus 2x2 minus x3 is equals to 0. Similarly, my third equation will move like this. That is x1 plus 0 times x2 plus 1 times x3 is equals to 0. So this is x1 plus x3 is equals to 0, because if you'll if you'll observe here, my the coefficient of this x2 is 0, so it's not required to even write that. So after this, I'm trying to convert, I will transform this three equation set of equation, it's known as equations. This set of equations I will change it to a matrix notation. How can I do that? It's known as, this capital A is known as the matrix of coefficients. This capital X is matrix of constants, and this is, sorry, matrix of variables, and this is equals to 0, that is matrix of constants. So now in this present case, we have all these constant is equals to 0. So let me just do that for one row. So if you'll observe, this is x1, so that means what? This is my first row of this matrix is for x1, this is for x2, and this is for x3, the column I'm talking about. Even so, and my first row here for this is for my first equation. Note it down. My columns are for variables, and my rows are for vectors. Rows are for vectors, columns are for variables. So in that way, I will write down this matrix of coefficient, then my x1, x2, x3 here, and this is equals to 0. After that, I'm forming here the augmented matrix. Augmented matrix, as in, it is nothing but the square bracket A, comma, B. But in this present case, our B is 0. So this is what is A, comma, 0. So this is what I'm talking about, my augmented matrix. So this is 3 cross 3 into this column. So this, now the order of this matrix becomes here 3 rows and 4 columns. What is my target here? My target is to reduce this matrix, this A matrix, because I'm not making any comment on this, because it's already a 0 matrix. It doesn't matter for me right now in the present case. But yes, it do matter whenever this z, instead of this 0, we have some other numbers, like other than 0, non-zero numbers. So my target is to convert this entire matrix into an identity matrix, like A matrix into identity matrix. Identity, or otherwise I can say that I wanted to change all these elements either in 0 or 1, right? Now, so if I will go for my first transformation, so this is like, this is also I have written purposely with in terms of words to make you understand, make this understand to everybody if you have a different notations. But let me go with this notation here. It's R2 minus R1. That means what? I'm the sec this is my base, you can say base. That means this row is going to change here, and I'm changing this with the operation r2 minus r1. So r2 minus r1, that is this will go, and this is the combination for the second row. So this is what is purposely I've shown each and every step in this example. Then r3 minus r1 will give me this type of, so you, for the reference, you just check with this matrix. This is my original matrix, and the next transformation is this. After transforming this matrix, I will get this one here. That is 1 1 0 0 0 1 minus 1 0 0 minus 1 1 and 0. Then again one more transformation I'll require, because my target is to convert all these elements either in zeros or in either in ones. Okay. Then r1 minus r2. So that means this is my base row. Base row. That means this row R1 is going to change. There is no change in R2, if you'll observe, because this is my second R2, R2. And always whenever I'm writing this type of the notation, at that time my first row will always change. There is this is a convention. Whichever the row number I'm writing here in the front, or in the first place, that is going to change. That means my r1 is going to change, r2 will remain same. Similarly, in the second operation or second transformation, r3 is going to change and my r2 will remain same. So after this transformations, I'm going to get this. Okay, now further more transformation you could go for, but what is my target here? Yes, just to reduce the matrix in such a way that it's easy for me to go for a solution. It's easy for me to go for a solution. Therefore I will just go with this, because anyways so this matrix is my end matrix. I'm considering this is my end matrix. So in this matrix, if we'll talk about echelon form, now again it's the one more concept is involved here. It's known as row echelon. Please bear with my handwriting. Echelon, let me just write down this. It's ECHELON. Few people are calling it as echelon, or few are saying it's echelon form. So what is it? This is, I have almost done with the echelon form, or I can say that reduction of this. Now at this point of time, I can easily find out my solution here, because my target is to go for to find out my x1, x2 and x3. Now what is the order? This is, if you'll observe here, this is my zero matrix, and the number of rows. So n minus r is equals to 3 minus 2, which is equals to 1 number of parameter. That means here my rank of this matrix is 2, and I have got my variables as 3. That is x1, x2, x3. These are the three unknowns I need to find out, but I've got my rank as 2. So in that case, I need to assume 1, 2, 3. That is x1, x2, x3. Out of these three, any one vector I need to assume, and that is nothing but the definition, or you can say the concept of number of parameters. So this is the first equation. I have got it. X1 plus 0x2 plus x3 is equals to 0. And my second equation is 0x1 plus x2 minus x3 is equals to 0. Right? Now out of this, now I have a choice of making any one as equals to any other parameter, as in this parameter is the number, because as we are dealing here with the real numbers, you can take it from other number, the number system, but here we are dealing here with the real number system. So that is why I'm taking this t belongs to some r, and I need to choose my t in such a way that my result will not get biased. Like I'm trying to take my t other than 0. So suppose my t is equals to 1 or t equals to minus 1, whatever. But for simplicity, anyways, I just have to find out my relation between these three vectors, and that is why I'm taking very easy or simple value as 1. So after assuming these values over here, either for x1 or x2 or x3, I'm going to get the set of equations are x1 as minus 1, x2 as 1, and x3 is equals to 1. Now again, you can make a choice from this too. That means I have got here two unknowns, because this is my coefficient as equals to 0. So that means what, this is not under the consideration, x1 is. Now I have got 2 here. So now it's a wise decision to assume x2 or x3 as some parameter, like as some number, so that you will get you will assume one and you will get the other one, and then taking those two values in the previous or the first equation, you'll get the third one. It's very simple. You have to just work on that. So x1 is -1, x2 is 1, and x3 is equals to 1. So if this set of equations I'm going to put in this equation. So if I'll put those values here, I'm going to get the relation between these three vectors as here. Minus a bar plus b bar plus c bar is equals to 0 bar. That means what? I have got some relation. And one more thing, you can just check it out here. These numbers, or you can say this scalars number x1, x2, x3, they are not 0, because we need at least one non-zero, but here we have got it all of them as non-zero because of this existence of the parameter, or you can say here. Therefore, I can make a comment, or I can conclude that a bar, b bar, and c bar, they are linearly dependent, because I could able to find out the relation between them. This is what is the relation between them. That means this equation is connecting a bar, b bar, and 3 bar all together, and that is why I could say that yes, they are depending on each other. That means if there is any change in b bar, my a bar and c bar is going to change. If there is any change in my a bar, my b bar and c bar is going to change. This is what is the meaning of linearly dependent vectors. Let us go for another example. So this is, I again, my question is check whether the vectors are linearly independent. Then as the things I have told you for the previous, this step is same as to the previous thing. Then this is also same. My suggestion for you all is, whenever I have completed the explanation for the first question, try to just copy down this question and try to reach up to the last statement, up to the last step. That is, up to here you try to reach, up to this step you try to reach, and then you just start the video and see what is the solution I have given, instead of. So that it's a very good idea, it's a very good way to check yourself, to introspect yourself, how much you have understood the explanation of the previous. The same I have formed here, ax equals to 0, then my augmented matrix. Then I'm going to go for with this transformations here, and after the transformations here, if you'll observe this matrix. Now I'm not going to explain you everything, you just have to do this as an exercise. So this is 1 1 1. That means if you'll observe this new number of parameters concept here, n minus r, that is 3 minus 3 is equals to 0. That is number of parameters. What is the meaning of this 0? That means what? I need not to choose the parameter. That means I need not to assume. What do you mean by that? I have got three unknowns, x1, x2, and x3, and I have got three equations. What is my first equation? My first equation is saying that x1 is equals to 0. Second equation is says that x2 is equals to 0. Third one is saying that x3 is equals to 0. That means what? I'm going to get directly the values of these three, x1, x2, and x3. All of them is equals to 0, right? And this is the meaning of this 0 parameters. I need not to take or assume any value from the real number. This automatically it will come with solving this equations. So I have got this, and therefore x1 equals to 0, x2 is equals to 0, and x3 is equals to 0. What do you mean by that? That means if I have got this, if I'm putting these values over here, I'm not going to get any relation between this vectors a bar, b bar, and c bar, and therefore I'm failing here to get equation or get a relation between a bar, b bar, and c bar, and therefore these vectors a bar, b bar, and c bar, they are linearly independent. I hope you must have understood what is linear combination, then linearly dependent, linearly independent vectors. With the examples you could able to do that. My suggestion for you all is, in this video at least you solve 5 questions, so that you will be thorough in this particular type of questions. Happy learning!